One.
Hello, today we are going to be solving this trigonometric identity, and to this end we are going to be using some basic identities and other not so basic, but I'm going to explain them here. Alright? So the first thing I'm going to do is to transform this tangent square. How I'm going to do so? So I know that tangent square of x is the same as secant square of x minus 1. Alright? So I know that tangent of x is equal to sine of x over cosine of x, and I know that secant of x is equal to 1 over cosine of x. Alright? So I can take this and write it as 1 over cosine of x, all this squared. Because what I'm doing is I'm taking just the secant and expressing that secant as 1 over cosine of x. So this square stays outside and this minus 2. But if we raise a fraction to a second power, this is basically the square of the numerator. So 1 squared is 1 over the square of the denominator, which is cosine squared of x minus 1. Okay? And now common denominator, cosine squared of x. So basically what I need to do is to rewrite this one as cosine squared of x over cosine squared of x. Common denominator cosine squared. And the numerator is going to be 1 minus cosine squared of x. Alright? But we know that another basic identity is sine square of x plus cosine square of x is equal to 1. So sine square of x, solving this for sine square, we get that sine square of x is equal to 1 minus cosine square of x. So all this becomes sine square of x divided cosine square of x. But again, I have the numerator raised to the second power and the denominator raised to the second power too, so I can rewrite this as sine of x over cosine of x, all these to the second power, and sine of x divided cosine of x is equal to the tangent, so this becomes tangent square of x. That is what we claimed from the beginning. Alright? So we have this not too basic identity, and maybe many of you already knew it. That is that tangent square of x is equal to secant square of x minus 1. I have two possibilities here. Either I transform both sides until I get the same thing, or I transform one of these two sides until I get the other. That's what I'm going to do. I'm going to transform this one to get this one, like I did here. Alright? So this is going to be tangent square is secant square of x minus 1 divided by secant of x minus 1. But the numerator is a difference of squares. Okay, we know that a squared minus b squared is equal to a minus b multiplied by a plus b. In our case, a is equal to secant of x and b is equal 1 because 1 squared is 1. So this difference of the square becomes secant of x minus 1 that multiplies secant of x plus 1. All this divided by secant of x minus 1. These two cancel with each other and all this becomes secant of x plus 1. But these two are real numbers, and we know that the addition of real numbers is commutative, so we can flip these two. This is the same as 1 plus secant of x, and now we know that secant of x is the same as 1 over cosine, so this is 1 plus 1 over cosine of x. That is exactly what we had on the left side. Okay, so the identity is proven. Thank you so much.